This is the first of several videos on simple linear regression. In this video, we are going to simply familiarize ourselves with the graph, the scatter plot, and the formulas, and then later on we'll look at how to develop the different values and answer questions around the topic of simple linear regression. Now, let's look at the formulas first. These appear on your formula sheet, usually under the heading of bivariate data. The reason we call it bivariate data is we're working with XY pairs. In the scatter plot, each one of these dots represents an observation, and each observation is identified by an X value and a Y value. We'll have more to say about that in just a moment. So the first thing you have to do, if you're only given the descriptive statistics for the problem, is to begin with the coefficient of correlation, which is R. R consists of the covariance, that's the numerator, Sxy, and then we're going to divide by the standard deviation of X and the standard deviation of Y. Thing to note is that the covariance value is the only value here that can either be positive or negative. Because R can be positive or a negative value, this is where the sign change comes from. Now, once you have that, you can go to the slope, which is beta 1 or b sub 1 if you want to call it that, which is R times the standard deviation of Y divided by the standard deviation of X. Now, with those two values in hand, we can move down to the y-intercept. The y-intercept is beta sub 0 or b sub 0, and is the average value of y minus the slope times the average value of x. Taking these three values then, and coming up with beta 1 and beta 0, we can write the regression equation y hat is equal to the y-intercept plus the slope times the independent variable x. And that's the equation of this line. Let's put it on here. Here's y hat is equal to b sub 0 plus b1 times x. Now let's take a look at the scatter plot. Typically, the values in x represent the independent variables, or also sometimes called the experimental variable. You would be manipulating this and measuring how the response, or dependent variable y, changes. Here we have a positive slope on our line, so that means as x increases, the value of y also increases. You'll also notice on here that the observations, these are the dots, rarely if ever coincide with the line. And the difference between the two values is called the residual value. Here, the residual value is large, and the predicted value is small. So that means we take the observed value and subtract the predicted value, we get a positive residual. However, down here, where the predicted value is large and the observed value is small, we end up with a negative residual, which can be used to answer certain questions as well. And this leads to a formula, often on formula sheets, but not always, so commit this one to memory. Residuals, then, are the observed value minus the predicted value. Oftentimes, that's y sub I minus y hat. So this is the general layout of the simple linear regression formulas and the scatter plot associated with them. We'll look at some examples about how to work with the formulas and construct the equation, but most importantly, we also need to talk about correlation, which we'll do in further videos.